So we looked last day, Cole, at this thing called an Atwood machine. All it was two masses hanging with and here was the magic part, a massless, frictionless pulley and massless ropes. But it really was the physics of an elevator. Every elevator has a counterweight so that the motor is only lifting the mass of the people in the car. It's not having to actually lift the car. And we said we could still use our winner minus loser. This is a job for a free body diagram. Winner minus loser equals the mass of all of them times A. And our strategy was we wanted to find the acceleration by writing an equation for both masses, for everything. And then to find an individual force, we looked at an individual mass. I'm going to say that again because this is going to be the key to the next part. If we knew both masses, we wrote an equation for both masses to find the acceleration. Then to find an individual force, we looked at an individual mass. I like example 5, I like example 5, I like example 5. Example 5 is a nice question. Brian, what are they asking me to find in example 5? Find M2, a missing mass, which we haven't done yet. Up until now, I've given you the masses, and I've said, go to it. What are they asking me to find, Brian? Now, here's the problem. Don't write this down. If I try using my winner minus loser method, I'm going to have M2s, and I don't know M2, and I'm going to have A's. My method of looking at everything, looking at both masses, is not going to work here. And it's not going to work here because I don't know mass 2. So first of all, Nick, is it fairly easy to see? It's not asking me to find the acceleration, the tension. It's pretty obvious something is weird here. I'm missing a mass. Instead, we're going to completely reverse the procedure. Instead of starting out looking at both masses, we're going to look at one mass. Which mass? The one mass that I know. Which mass do I know, Brian? M1? This is a job for a free body diagram on M1. What are the forces acting on M1? Get the obvious one. And I'll call that M1G. What else? Which way? Okay. I'm going to temporarily ignore this one. Don't color it over, but I will in my mind. And I'm going to write an equation just for this. Who's winning? How do I know? Okay. If I give you, and I will give you a question with a missing mass, I have to tell you the direction that things are accelerating. So let's even add a little arrow right there, and let's say that that's A, and that's A. We're just going to write an equation for mass 1. You're correct. Say it again. Who's winning? Who's losing? So it's going to be minus M1G. What does that equal? Which M? Because we're only looking at mass 1. Now, why is that handy? I already know tension. They gave it to me. I can find the acceleration. The only other way I can do this question, Mateo, is I can give you the acceleration. You're going to find tension. But I need tension and I need acceleration before I can find mass 2. Let's find the acceleration. How would I get the A by itself? So the acceleration is going to be tension minus M1G divided by M1. Yes, it will. The acceleration is going to be tension 56.5 minus 3.2 times 9.8 divided by 3.2. I know this question didn't say find the acceleration. It said find the mass, but I need the acceleration to find the mass. I get bracket 56.5 minus 3.2 times 9.8, close bracket, divided by 3.2. Double check me. Do you get an acceleration of 7.85625? And because I know I'm going to use this to find my actual answer, I'm going to avoid rounding off if I can. I'll carry all the sig figs. I won't put a box around this. This is not my final answer. Brian, what did you say they're asking me to find? Let's go do a free body diagram for mass 2. What are the forces acting on mass 2? Get the obvious one. M2G. What else? Is there a normal force? Is it sitting on a surface? Okay. Let's write an equation for mass 2. Who's winning in mass 2? Because it's accelerating down. Who's losing? What does winner minus loser always equal? So it'll be M2A. Let's do a quick check. M2 is what I'm trying to find. Do I know G? Do I know T? Do I know A? So I should be able to find M2, but there's a problem. How many M2s do I have in this equation? 2. How many would I prefer? 1 would be nice. You know what? Let's get the M2s to one side, to the same side. So I'm going to plus the tension there and minus the M2A. I'm going to do the swappy dance. When I do that, Tim, I get M2G minus M2A equals tension. How many M2s do I have? 2. How many would I prefer? 1. Cool. You know, it'd be really cool. Besides you being awake, you know, it'd be really cool. It would be really cool if there was a Math 9, yes, a Math 9 mathematical operation that I could pull out of my back pocket and change this from 2 M2s into 1 M2. And there is. They're not like terms. Well, they sort of are, but I don't want to gather like terms here. I want to do something else instead. Something to do with brackets, yeah. In fact, it's the math F word, not the F word you're thinking of. Factor. Is there an M2 in everything on the left? Isn't that a GCF? Which is Math 9. Okay? Don't write this down, just watch. I'm going to write the same equation underneath it and make it look prettier. I'm going to write y5 minus yx equals a. Is there a y in everything? Could you write this as y bracket 5 minus x? Cole, I heard you saying something to do with brackets. So you can make a little note here. Factor. If I abbreviate GCF, do you all know what that is? Greatest common factor. Because, Brian, if I do that, if I factor out the M2 bracket, and then it's going to be G minus A left behind in the brackets, that equals tension. How many M2s do I have now? Woohoo! How would I get the M2 by itself? What do I do with that bracket? What's that bracket doing to the M2? Multiplying, you say? So how will I move that bracket over? Divide, you say. Are you telling me that mystery mass 2 is going to be the tension divided by G minus A? I can drop the bracket because there's an implied bracket there. And that's going to be your strategy. I am going to give you a question where you're missing a mass. What you're going to do is, find the missing mass by not looking at it. Look at the mass that you do know, write an equation for it, and Mateo, you'll either find tension or acceleration. Then you'll go to the mystery mass. You will often end up with 2 of the mystery masses. Get them the same side, factor it out, zip zap. I've scrolled down. What was tension? 56.5? 0.8, Mr. Duke, 0.5. And then G, 9.8 minus 7.85625. You know I'm going to use my answer button. So 56.5 divided by bracket, 9.8, take away answer button. How big is the mystery mass? It's exactly 29.06752. I'll call it 29.1. Units, Brian, it's a mass. Kilograms is the unit for mass, not grams. Let's do one more like that. In example 5, I gave you the tension. We found the acceleration. Here, I'm giving you the acceleration. We're going to find the tension and then go look at mystery mass number, missing mass. Hannah, what mass am I trying to find here? Eventually. So which mass am I going to look at first? The one that I know, which is? This is a job for a free body diagram. What are the forces acting on mass 2? Get the obvious one. I totally agree. What else? Who's winning? This is why I had to tell you which way M2 is accelerating. Which way is M2 accelerating? So let's make a little note that that's A, and now I can get my equation. Who's winning? Good. Who's losing? What's that going to equal? Why isn't it M all A? Because we're only looking at the one mass, because I don't know the other mass. So I'd like to find tension. In fact, that's what A is asking me to find. Okay, how do I get the T by itself, Hannah? The swappy dance, sure thing. So if I hear you correctly, you're telling me tension is going to be the M2G drops down like a domino minus M2A. Tension is going to be M2 4.3, 9.8 minus 4.3, 2.5. 4.3 times 9.8 minus 4.3 times 2.5. And I get 31.39. Anybody else? Am I wrong? Am I wrong? Yes, I'm good. Okay. And because I know I'm going to use this, I'll try not to round off unless I absolutely have to. So I can go 31.39 newtons. I'd probably report it as 31.4, but I've got that on my calculator now, stored. Now, to find mass 1, let's draw a free body diagram on mass 1. Hannah, what are the forces acting on mass 1? Get the obvious one. I'll call that M1G. What else? Good. What's my equation for mass 1? Who's winning? Yes. Who's losing? Equals M1A. Why not M1 plus M2? Because I'm only looking at mass 1. How many M1s do I have? How many would I prefer? It'd be kind of nice if I... Oh, let's get them all to the same side at least. Here, it's not going to be the swappy dance. I'm just going to plus the M1G over. I'm going to get tension equals M1A plus M1G. How many M1s do I have, Hannah?
2.
How many would I prefer? How could I... It'd be cool if there was a grade 9 mathematical operation that I could pull in my back pocket. Oh, there is? What? GCF. Who's in... Anybody here math 12? Do I have grade 12s here in this block? I believe it or not, I've just planted a hugely, hugely, hugely useful seed for all of you that are taking pre-calc 12 next year. There's going to be a series of equations where you're going to have monstrosities all by... How can I get them by themselves? Oh, do the monstrosities appear in everything? Factor them out. Now you've only got 1 instead of 5. So you're telling me, Hannah, that I can write M1 bracket A plus G? And this is why, don't memorize this. I noticed in the previous one, it was G minus A on the bottom. Here, it's G plus A on the bottom. I've never bothered memorizing this. I just derive it. It takes me a couple of seconds. How do I get the M1 by itself, Hannah? What did I write T1, Mr. Dewick? M1 is going to be T divided by A plus G, and tension, I have this stored on my calculator, 31.39. A was 2.5. G was 9.8. Good yawn, Cole? Yeah. And I get mass 1 has to be 2.55 kilos. Now, last class, did I show you I've showed you the non-Newtonian Oobleck video, right? Have I showed you the Zion protective gear? I think I did with you folks. The bulletproof potential body armor thingy. So I showed that to you already. My videos have been different with different classes. So for now, for your homework, number 1, number 2, three is good. In number 4, I'm not giving you either mass, but in number 4, I'm giving you both tension and acceleration. Write an equation for mass 1, write an equation for mass 2. You might find that you have two M1s. How would you get them by themselves? Get them to the same side, factor them out, and divide. So you try number 4. I haven't done one quite like that. I've done very, very close. Let's skip 5. Let's try number 6. 7 is good. 8 is good. 9 is good. And I have a take-home quiz for you too. We're done the unit. That's forces. On Wednesday, I think we'll have a study guide. Friday is probably going to be a review period. Did I say when your test was? Did I say Friday or Monday? Forces test.
Monday.
You folks want the forces test Friday or Monday? Let's vote. Who would like the forces test this Friday? Okay, who would prefer the forces test Monday? Okay, so we'll go Monday. Okay. So on Wednesday, you'll get a study guide as well.